Hey, Hux. So, again, we're how is energy obtained from a chemical reaction? So we really kind of talked about that a little bit, but um, now that we know what a chemical reaction is and the different types of them, now we need to be able to balance those chemical reactions because remember, we can't create any energy or we can't create any matter. So that means that what we start with, we have to end with. And so we're going to do balancing equations. And so your learning target at the end of this lesson is I will balance chemical equations by correctly adding coefficients as needed. Okay, so the law of conservation of mass is what I was just talking about. So it states that the matter cannot be created or destroyed. That means that to balance these two equations out, I can't just add another oxygen, right? Or I can't just add two more hydrogens. I have to actually think about how many methanes do I need to mix with how many oxygens in order to get a comparable carbon dioxide and water. Okay, so in the chemical reaction, the amount of particles in the reactants, remember that's the one on the left hand side, must equal the amount of particles in the product, the one on the right hand side. Okay, when they're equal, we say that the reaction is balanced. So here's an example. Same example as what we were just working with. So we have methane, which is CH4, and oxygen, and we're going to end up with carbon dioxide and water, right? This is a combustion reaction. And so if we add up the number of particles on each side, then we need to be able to say we have the same number on the other side. So we have one carbon, and then attached to that are four hydrogens. And then here we have two oxygens. Okay. On the other side, for CO2, we have one carbon and two oxygens. And then for the water, we have two hydrogens and one oxygen. So if we put them all together, right, there's one carbon. Okay. The red ones are the oxygens. So that's 1, 2, 3. And the green ones are the hydrogens. There's two of those. Now, if we look at this side, we have one carbon, one carbon. Those balance, but here we have four hydrogens and here we have two hydrogens. Those are not balanced, right? They need to be the exact same on both sides. If any one number isn't the same, it's not balanced. As opposed to the one on this side where we've added a coefficient. And so now we have two oxygen molecules. So that means we have four oxygens. And so then if we look at both sides after balancing the hydrogen, the waters on this side, we do find that we have the same number of each atom on both sides. So this one is balanced. Okay. So let's walk through one. And then the first thing that you want to do is you always want to start with counting. Okay. We're always going to start with counting the number of atoms on each side of the arrow. So that's what we're going to do right now. We're going to count the reactants and we're going to count the products and we're going to see if they're the same. If they are, we're going to say that it's balanced. If they're not, we're going to say it's unbalanced. So one thing to keep in mind is that a coefficient, okay, that's the number of molecules. It affects all of the atoms in that molecule. Okay, so this coefficient 2 affects the hydrogens and the oxygens. Okay, as opposed to the subscript is what makes it the compound that it is, right? If we change that subscript, we have a whole different molecule. So we never ever change the subscript. Okay, and that is the number of atoms, and it only affects that atom next to it. So this 2 only applies to the hydrogen. And we never want to change that, or we would not have water anymore. Okay? So make sure that when we move on into balancing, that we're only working with these front numbers. Okay? But you do need to understand how to use the subscript. Okay, so for our first example, we have 2 sodiums plus a chlorine molecule, and that's going to be turn into 2 sodium chlorides. Okay, so the first thing we want to do is we want to look at, I always go from left to right just because that's the way I read. You can do it in any order you want. Okay, so here I have 2 sodiums. So down here I'm going to write my reactant is sodium, and I have 2 of them. Okay, in my next blank I have chlorines, and this 2 means that there are 2 chlorine atoms, so I'm going to say that there are 2 of them. Okay, on this side we're going to have the same atoms. Okay, and then so here we have 2 times 1 sodium atom, so that's 2. And here I have 2 times 1 chlorine atom, so that is 2. Now, because these numbers match, this one is balanced. Okay, here's our second example. In this one, I have hydrogen phosphate plus phosphorus chloride equaling PCl5 plus water. Okay. So I have hydrogen, right? That's my first one. And there are 3 of those. And then here I have a phosphorus, and there's 1 of those. And then I have an oxygen, and there are 4 of those. Then I go over here, here's another P, so I have to add 1. And then a Cl, there are 3 of them. Okay, so if I add these 2 together, I get 2. So there are 3 hydrogens, 2 phosphoruses, 4 oxygens, and 3 chlorines. On this side, I'm going to do the same order. So H, I don't have an H here, but I have 2 here. P, I only have the 1 P. And then here I have an O, so there's only 1 O. And then chlorine, Cl, there are 5 of those. So now if I look at them and I compare them, they are not the same. So this one is unbalanced. Okay? Because the 2 sides don't equal each other. So you should be prepared to be able to count all of the atoms on both sides, the reactant side and the product side, and determine whether or not the equation is balanced or unbalanced.